All right, let's jump right into it. We are living in an absolutely wild era of technology. I mean, you can generate an entire REST API, a complex React dashboard, or some massive SQL query in under 5 seconds. Tools like Cursor, Claude, and GitHub Copilot are without a doubt the most powerful productivity boosters we have ever seen in the history of software development. But there is a dark side here that simply isn't getting enough attention, and that's exactly what this explainer is all about. We're going to unpack how, surprisingly, AI coding tools are actually making bad developers worse.
There's this quote that hits the nail right on the head. And honestly, it's a bit of an uncomfortable truth. If you don't already have a rock-solid grasp of system architecture, memory management, and clean code principles, AI is not some magical ticket to becoming a 10x engineer. It's really not. Instead, it's turning you into a 10x code generator of unmaintainable, fragile spaghetti code. Without those fundamentals, these tools just accelerate the creation of incredibly bad software.
Think about what we call the AI spaghetti phenomenon. The core issue here is that AI models write code locally, but your systems, they run globally. When you give an AI an isolated prompt, say for a payment endpoint, it gives you a really clean working local output. It handles the charge, it returns a nice little 200 OK status, and the syntax looks totally pristine. But the global system reality is vastly different. You have to ask, is that endpoint idempotent if a user's network drops and they click pay twice? Did the AI create a database transaction to prevent inconsistent data? How is this code going to handle your database connection pool limit when you suddenly hit 5,000 requests per minute? The AI doesn't see that global reality. So an inexperienced developer copies the syntax, pushes to production, and 2 weeks later the whole system crashes under load.
So to fix this, we're going to walk through a 3-part roadmap today. First, the 3 AI developer traps. Second, an architect-first AI framework. And finally, some real-world AI refactoring.
All right, part 1, 3 AI developer traps. Let's identify those bad habits.
Trap number 1 is what we call the illusion of competence, or, blind copy pasting. You give the AI a prompt, you grab the generated code block, you paste it into VS Code, and hey, as long as there are no angry red squiggly lines from your linter, you just move on. It feels great, right? Green check marks all around. But the trap here is relying on those check marks without actually being able to explain, line by line, what that code is doing under the hood.
Then there's trap number 2, debugging by prompting. Oh man, we have all been tempted by this. Your code throws a massive error, and instead of rolling up your sleeves, reading the stack trace, or firing up a debugger, you just copy-paste the error right back into Claude or ChatGPT. You enter this frantic blind loop of trying random AI-suggested patches until something magically works. The real danger? You fix the bug without ever understanding why it broke in the first place, leaving the underlying architectural flaws totally untouched.
And trap number 3 is feature-level thinking. This is where you build things one by one, asking the AI for, say, a login button today and maybe a user profile query tomorrow, but you're doing it without any overarching blueprint or interface contract. Because you lack a system-level plan, your project eventually morphs into this Frankenstein monster. It becomes a tangled mess of disjointed patterns, duplicated logic, and wildly mixed design paradigms.
Moving on to part 2, the architect-first AI framework. Here are 3 steps to senior-level execution.
Look, senior engineers know that AI is a fantastic executor, but it is a downright terrible architect. To keep your codebase healthy, you've got to follow 3 strict rules on every single project. Number 1, architecture first, code second. Number 2, prompt for interfaces. And number 3, enforce strict code reviews. Let's break these down.
Rule 1, architecture first, code second. Seriously, never ever ask AI to write implementation code until you have defined the architecture. You need to sketch out your data flow between components, define your database schemas, and establish your error handling strategies before a single line of code gets written. Here's a great pro tip for you. Prompt the AI to act as a reviewer first. Feed it your proposed system design and say, hey, here's my design for a rate-limited API gateway. Challenge this logic. What are the bottlenecks or race conditions? Let the AI stress test your architecture before it writes anything.
Rule 2 is all about prompting for interfaces, not concrete implementations. Instead of begging the AI for some unreadable 200-line mega function, ask it to create a strict API contract first. For example, if you define a really clean TypeScript interface specifying exactly what a payment processor does, with a charge function and a refund function that have strictly defined inputs and outputs, it changes the game. When you force the AI to adhere to a tight contract like that, the generated code stays modular, it's a breeze to mock, and it becomes incredibly easy to unit test.
Rule 3.
Enforce strict code reviews. You absolutely must treat AI output exactly like a pull request from a brand new intern on your team. Run it through these 4 verification questions. First, memory and resources. Did it leave any connections or listeners open? Second, error boundaries. What actually happens if the downstream database completely tanks? Third, security. Are the inputs sanitized, authenticated, and rate limited? And finally, readability. Can a human engineer understand this logic in 30 seconds? If the answer to any of those is no, you've got to refactor it immediately.
That brings us to part 3, real-world AI refactoring. Time to upgrade your code. Let's talk about the exact difference between an AI-assisted junior developer and a true system-minded engineer. Your standard, raw AI-generated output often just catches generic errors, relies on really messy nested logic, and performs sequential database queries without any transaction safety whatsoever. It is literally a ticking time bomb. But when you refactor that code, that's where you add early guard clauses to exit and validate input instantly. You wrap your database operations in explicit ACID transactions to ensure total data integrity, and you map custom domain errors so your API returns meaningful HTTP status codes. That is what it means to actually upgrade your code.
So what does this all boil down to? It comes down to the number 0. AI is an incredible multiplier, no doubt about it. But mathematically, 0 times 10 is still 0. If your engineering fundamentals are 0, AI is just going to help you build awful software a lot faster. But if you double down on system architecture, clean code, database design, and security, AI makes you absolutely unstoppable.
Which wraps up our explainer today. I want to leave you with a question to chew on. How much do you actually rely on AI tools in your daily workflow? And honestly, what is your absolute biggest pet peeve with AI-generated code? We're navigating a totally new frontier of development here, and recognizing these flaws is the only way we evolve. Hopefully, this framework helps you build better, much more resilient systems. Keep questioning the code, stay curious, and we'll catch you in the next explainer.